Tell me about a time you solved a complex technical problem. Introduction. This is one of the most common behavioral interview questions for software developers. Interviewers ask this question to understand Q. How you analyze problems. Q. How you debug complex issues. Q. How you find root causes. Q. How you work with others. Q. How you handle pressure. Q. How you measure results. Q. How you communicate technical solutions. This question is especially important for check. Java developers. Check. Backend developers. Full stack developers. Check. Senior software developers. Check. Team leads. Check. Cloud engineers. Production support developers. The best way to answer this question is by using the STAR method. STAR means S. Situation. Explain the background. T. Task. Explain your responsibility. A. Action. Explain what you personally did. R. Result. Explain the final outcome. A good interview answer usually spends 10% situation, 10% task, 60% action, 20% result. The most important part is the action section, because interviewers want to know what you personally did. Question. Tell me about a time you solved a complex technical problem. Example 1. API performance issue situation. In one of our production applications, we started seeing intermittent performance issues during peak business hours. API response times increased from under 1 second to more than 10 seconds, which affected customer experience. Task. As a senior software developer, I was responsible for identifying the root cause and implementing a solution without causing production downtime. Action. I started by analyzing application logs, API response times, database execution plans, and monitoring dashboards. I compared normal traffic behavior with peak hour behavior to understand when and where the slowdown was happening. After investigation, I found that several database queries were performing full table scans on large tables. Some queries also had unnecessary joins and were fetching more data than required. To solve the issue, I worked with the database team to design proper indexes. I also rewrote some queries to reduce unnecessary joins, fetch only required columns, improve query execution time, reduce database load. After that, I introduced caching for frequently requested data to reduce repeated database calls. I also created performance tests to validate the improvement before deployment. Result. Average API response time improved from more than 10 seconds to under 2 seconds. System throughput improved during peak traffic periods. Customer complaints related to performance dropped significantly. The same optimization approach was later used by other teams as a best practice. Why this answer works. This is a strong answer because it shows check. Root cause analysis, database optimization, performance tuning, production ownership, collaboration, measurable impact. Example 2. Production memory leak situation. In one of our Java microservices, the application started restarting frequently in production. The issue was not happening during normal testing, but it appeared after the service ran for several hours under high traffic. Task. I was responsible for identifying the root cause of the instability and implementing a fix to prevent further production incidents. Action. I first reviewed application logs, container restart history, and memory usage metrics. I noticed that memory usage kept increasing over time and was not being released properly. To investigate further, I collected heap dumps from the affected environment and analyzed object allocation patterns. After reviewing the heap dump, I found that a large number of objects were being retained in memory because of an unbounded cache inside the service. The cache was storing user-related lookup data, but did not have proper eviction rules. To fix the issue, I replaced the unbounded cache with a controlled caching strategy. I added maximum cache size, time-based eviction, proper cache key design, monitoring for cache hit rate, and memory usage. I also added performance and load tests to simulate long-running traffic conditions before releasing the fix. Result. After deployment, the service stopped restarting unexpectedly. Memory usage became stable during peak traffic. Production incidents related to this service were reduced, and we added cache monitoring as part of our standard production checklist. Why this answer works? This answer is good because it shows C. JVM troubleshooting. C. Heap dump analysis. C. Memory leak investigation. C. Production debugging. C. Long-term preventive improvement. Example 3. Kafka message duplication issue situation. In one of our event-driven systems, users reported duplicate updates in the application. After initial investigation, we found that some Kafka messages were being processed more than once during retry scenarios. Task. I was responsible for identifying why duplicate processing was happening and making the message processing reliable. Action. I started by reviewing Kafka consumer logs, retry behavior, and offset commit logic. I found that when the downstream API failed, the consumer retried the message. In some cases, the original operation had already completed, but the offset was not committed because the response failed or timed out. This caused the same message to be processed again. To solve the issue, I introduced idempotency in the message processing flow. I added a unique event ID for each message and stored the processing status in the database. Before processing a message, the consumer checked whether the event ID had already been completed. If the event was already processed, the consumer skipped duplicate processing safely. I also improved error handling and separated retriable errors from non-retriable errors. Additionally, I added monitoring for duplicate event count, retry count, failed messages, dead letter queue messages. Result. Duplicate updates were eliminated. The Kafka consumer became more reliable during downstream failures. The system handled retries safely, and the same idempotency pattern was later reused in other event-driven services. Why this answer works? This is a strong backend answer because it shows Kafka knowledge, idempotency, distributed system thinking, retry handling, production reliability, data consistency. Example 4. Slow batch job situation. Our nightly batch job was taking more than 6 hours to complete. This created delays for downstream reporting systems and affected morning business operations. Task. I was responsible for analyzing the batch job and reducing the processing time without changing the business logic. Action. I started by reviewing batch job logs, database queries, file processing logic, and step execution times. I found that the job was processing records one by one and making repeated database calls inside a loop. This caused thousands of unnecessary database round trips. To fix the issue, I redesigned the batch process to use chunk-based processing. I also improved the database interaction by using batch inserts and batch updates. I made the following changes. Check. Increased chunk size carefully. Check. Reduced database calls. Used batch operations. Moved repeated lookups into cache. Check. Added indexes for frequently filtered columns. Check. Added better logging for each batch step. I tested the changes with production-like data volume before deployment. Result. The batch job execution time was reduced from more than 6 hours to under 2 hours. Downstream reporting systems received data earlier. The business team was able to start morning operations on time. The improved batch design also made future troubleshooting easier. Why this answer works? This answer is good because it shows batch processing knowledge, database optimization, performance improvement, production data handling. Measurable result. Example 5. Authentication failure after deployment situation. After a production deployment, some users were unable to log in to the application. The issue did not affect all users, which made it difficult to identify the root cause immediately. Task. I was responsible for investigating the login failures and restoring normal authentication behavior quickly. Action. I started by checking application logs, authentication service logs, and recent deployment changes. I noticed that the failures were happening only for users with specific roles. Then, I compared the new security configuration with the previous working version. I found that a recent Spring security configuration change had accidentally restricted access to one of the authentication-related endpoints for certain user roles. To fix the issue, I updated the security rules and verified that the correct endpoints were permitted. I also added automated tests for role-based authentication scenarios to prevent the same issue from happening again. Before redeployment, I validated login for normal users, login for admin users, token generation, token validation, role-based access rules. Result: the login issue was resolved quickly. Affected users were able to access the application again. The new automated tests improved confidence in future security-related deployments. Why this answer works? This answer is strong because it shows security troubleshooting, Spring security knowledge, production issue handling, regression prevention, testing improvement. Example 6, database deadlock issue situation. In one of our transaction-heavy applications, we started seeing intermittent database deadlocks during high-volume processing. The issue was difficult to reproduce because it happened only when multiple requests updated related records at the same time. Task: I was responsible for identifying the cause of the deadlocks and improving transaction reliability. Action: I reviewed database deadlock logs, transaction boundaries, and the order in which tables were being updated. I found that 2 different code paths were updating the same tables in different orders. One process updated the customer table first, and then the account table. Another process updated the account table first, and then the customer table. When both processes ran at the same time, they sometimes blocked each other and caused a deadlock. To solve the issue, I standardized the update order across both code paths. I also reduced the transaction scope by moving non-critical operations outside the transaction. In addition, I added retry logic for safe retryable deadlock scenarios. I worked with QA to create concurrency test cases to validate the fix. Result: the deadlock frequency dropped significantly. Transaction reliability improved during high-volume processing. The team also adopted a standard guideline for transaction ordering in future development. Why this answer works? This is a strong answer because it shows concurrency knowledge, transaction management, database troubleshooting, root cause analysis, long-term engineering improvement. Example 7, third-party API timeout issue situation. Our application depended on a third-party API for customer verification. During peak hours, the third-party API became slow, causing our application requests to time out. Task: I was responsible for improving the reliability of our application, even when the external service was slow or unavailable. Action: I started by reviewing API timeout logs, external service response times, and failure patterns. I found that our application was waiting too long for the external API and did not have proper fallback behavior. To solve the issue, I implemented better timeout configuration and retry logic. I also added a circuit breaker pattern to prevent repeated calls to the failing external service. When the external API was unavailable, we returned a controlled response and allowed the request to be retried later. I also added monitoring and alerts for CAC, third-party API latency, CAC, timeout count, CAC, retry count, circuit breaker open state, CAC, failed verification requests. Result: the application became more stable during third-party API slowdowns. Timeout-related failures reduced significantly. The system handled external service issues more gracefully, and users received better error responses instead of random failures. Why this answer works? This answer is good because it shows yes, API integration knowledge, timeout handling, retry design, circuit breaker pattern, resilient system design. Example 8, incorrect data in report situation. The business team reported that some daily reports were showing incorrect totals. The issue was serious because the reports were used for business decision-making. I was responsible for identifying the data mismatch and correcting the issue without affecting valid historical data. Action: I started by comparing the report output with source transaction data. I reviewed the SQL queries, aggregation logic, date filters, and batch processing rules. After investigation, I found that the report query was using the wrong time zone conversion for transactions created near midnight. Some transactions were being counted under the wrong business date. To fix the issue, I updated the date conversion logic and aligned it with the official business time zone rules. I also added test cases for boundary scenarios. CN, transactions near midnight, daylight saving time changes, month-end dates, different time zone inputs. I worked with the business team to validate corrected reports before releasing the fix. Result: the report totals became accurate. The business team regained confidence in the report data. The additional test cases helped prevent similar date-related issues in future reporting changes. Why this answer works? This answer is strong because it shows careful validation, SQL debugging, time zone handling, business impact, careful validation, best short answer version. If you need a short interview answer, you can say, in one of my production applications, we had a performance issue where API response time increased from under 1 second to more than 10 seconds during peak hours. I was responsible for finding the root cause and fixing it without downtime. I analyzed logs, monitoring dashboards, and database execution plans. I found that some queries were doing full table scans on large tables and also had unnecessary joins. I worked with the database team to add proper indexes and rewrote the queries to fetch only required data. I also introduced caching for frequently accessed information and created performance tests to validate the fix. As a result, average response time improved from more than 10 seconds to under 2 seconds. The system became more stable during peak traffic, and the same optimization approach was later adopted by other teams. Common mistakes to avoid. 1. Giving a generic answer. Bad answer. I solved a difficult bug in the application. Better answer. Explain the actual problem, investigation, fix, and result. 2. Not explaining your personal role. Bad answer. The team fixed the issue. Better answer. I analyzed the logs, identified the slow query, worked with the database team, and validated the fix. 3. No measurable result. Bad answer. The application became faster. Better answer. API response time improved from 10 seconds to under 2 seconds. 4. Too much technical detail. Do not explain every line of code. Explain the technical problem in a way the interviewer can follow. 5. Blaming others. Avoid saying, the database team created bad queries. Better. I collaborated with the database team to review execution plans and improve indexing. Best practices for answering this question. Check. Use the STAR method. Check. Choose a real technical problem. Check. Keep the situation short. Check. Focus mostly on your actions. Check. Explain root cause analysis. Check. Mention collaboration. Check. Include measurable results. Explain business impact. End with what you learned. What interviewers are looking for. Interviewers want to see whether you can stay calm under pressure, debug systematically, identify root cause, communicate clearly, collaborate with teams, improve system reliability, prevent repeated issues, understand business impact. For senior roles, they also want to see check ownership, check production thinking, check architecture awareness, check mentoring, long-term improvements. Final summary. Tell me about a time you solved a complex technical problem. Is a very important interview question for software developers. The best answer should include clear problem, your responsibility, investigation steps, technical solution, measurable result, business impact. Good examples include check, API performance optimization, check, production memory leak, check, Kafka duplicate message issue, check, slow batch job, check, authentication failure, check, database deadlock, check, third-party API timeout, check, incorrect report data. The strongest answers are specific, structured, action-focused, and result-oriented.